So I assigned this integral as one of my homework questions for my Calculus 2 class, and I thought it's pretty nice, so let's talk about it. We have the integral of 1 over x times the square root of x minus 1. So first, let me just talk about it. If we had the integral of 1 over x times the square root of x squared, if we have the square right here, this right here, it's easier in the sense that there's a much clearer indication of, let's just do trig sub. Because we have the x squared minus 1 inside of the square root, let x equal secant theta. That way we can see dx equals secant theta, tangent theta, d theta. And if you plug that in, you will see that secant squared theta minus 1 is equal to tangent squared theta. This is just a trig identity. And you will get the integral 1 over dx is secant theta times the square root. If you put this inside here, you just get tangent square theta. And dx is all that, so secant theta tangent theta d theta. In fact, this and that cancel. And you see secant theta and that cancel. Tangent theta cancel. You're just integrating 1 in the theta world. So you just get theta. If you look back here, you see that theta is equal to inverse secant. And then we're done. And in fact, if you remember the derivative of inverse secant is equal to this, then you can actually just put on the result as well. So that's okay. But now the problem is that we don't have the square right here. So what do? Maybe we do u sub instead. And usually if we do u equal the inside, which is x minus 1, then we see du is equal to just dx. And that will be the integral 1 over dx. Well, it's not allowed in the u world, but it's okay. We can add 1 to both sides. U equals, I want to say u is equal to plus, no. U plus 1 is equal to x. So I can put that right here, u plus 1, parentheses that, and then square root of the inside is the u. And we have the du on the side. And now what? You can distribute a little bit. You can still finish it, still doable. You try it. But it might not be too clear from here, in my opinion. The trick is you have to look at this u as square root of u squared and then do another u sub. Yeah, you can go from there. It's doable. But I want to show you though, sometimes maybe you want to let u equal the whole square root. I think it works out very well. So let's have a look. Alright, so for this one, I'm actually going to let u equal square root of x minus 1. And then because we have to get the x right here and also the dx, so let's isolate the x first. Square both sides, and then add 1. So x equals u squared plus 1. Differentiate now. Dx equals, the derivative of this is 2u, and then du. Now, take this to the u world, we get the integral. The x is u squared plus 1. And then put parentheses around it, and then we have square root of u, well, the whole thing is u now, right? Square root of x minus 1 is the u. So multiply by u. 1 on the top. Dx is 2u du. Now this time, you see that the u and u cancel out right away. Very nice. You can put the 2 all the way in the front, and then look at the integral of 1 over u squared plus 1. Now, do we recognize the derivative what function will give us this? Yes. Inverse tangent. Yes. So the answer is 2 times the inverse tangent of u. And I'm not going to put on the plus c yet because I haven't gone back to the x world. So the last step, u is the whole thing, right? Square root of x minus 1. And then plus c. And then we are done. Very nice. In fact, when you have an integral with this structure, you can let u equal to the square root and it works out very well. Depending on how you are going to change the exponent here, so I can give you guys this one for you to try as well. Integral 1 over x times the square root. In fact, if you have x to a second power, letting u sub equal the square root part right here, it will also work very nicely as well. But why don't you guys try the third power? Because for this one, the regular u sub is going to be, I don't know, a lot of us will just get stuck after the u sub because the expression is not going to be so nice. And yeah, the key is this whole thing is a u. So keep in mind, sometimes when you are dealing with an expression, maybe you have to let u equal the whole square root part. Maybe it works out really well. Unfortunately, I have to tell you, there's no one method that will solve all the integrations. That's just not possible. So you just have to give these kind of things a try and hope for the best.